So on to the second problem of the 2006 MIT Integration B finals. It's the integration of indefinite integral of square root of 1 minus x over 1 plus x. So this is a fairly easy problem as well. Let's see how we may be able to solve it. First method is what we do is we multiply both the numerator and denominator by the square root of 1 minus x. And what that means is that in the numerator you have the square of the square root of 1 minus x, and the denominator you have the square root of 1 minus x times 1 minus x. So that becomes in the numerator 1 minus x over the square root of 1 minus x squared. And so we can separate that into two separate integrals. We have the indefinite integral of 1 over square root of 1 minus x squared minus the indefinite integral of x over square root of 1 minus x squared. We can see here in the second part, this just happens to be the derivative of the square root of 1 minus x squared. And in the first part, this is a popular integral, which is the arcsine of x. So eventually, our problem becomes the arcsine of x plus square root of 1 minus x squared plus the integration constant. And that is as simple as that. That's the first method. Second method, we could go the long way of just trying to, it's pretty much similar to the first method, but the second method is we'll just go ahead and say, okay, let x be equal to sine theta, such that dx d theta is cosine theta, such that you can substitute for dx with cosine theta d theta. And that means that now we have 1 minus x over square root of 1 minus x squared being equal to 1 minus sine theta over 1 minus sine squared theta times, in place of dx, we have cosine theta d theta. Now, 1 minus sine squared theta is cosine squared theta, square root of that is cosine theta. So in the denominator, we have cosine theta. And so the cosine theta in the denominator cancels with the cosine theta in the numerator, and we are left with a simple integral of 1 minus sine theta. So that is easy to solve. We have the integral of 1 minus sine theta being equal to theta plus cosine theta plus c. Now, since we know that cosine theta is the square root of 1 minus sine squared theta, but also x was said to be sine theta, it means that in place of theta here, we're going to have arc sine theta, right? And in place of square root of 1 minus sine squared theta, we're going to have 1 minus x squared. So the answer to our 1 minus x over 1 plus x square root is the integral is integrated is arcsine of x plus the square root of 1 minus x squared plus integration constant. And that is the second way we may be able to have solved it. The two methods are pretty much similar. One is just abbreviated, but the other goes a long way into just showing the steps that you could have undertaken if you didn't memorize the formulas. Some things, it helps to remember things, but sometimes if you don't, you just have to do it the hard way.